Hello friends, I am going to take now the monostable multivibrator with input logic. So until now we have studied triple five timer circuit for a monostable and stable operation. Now let's say slightly modified and with using a TTL circuit in a 7-4 series. There are two important IC which is generated, that is 74121 and 74123, which are non-retriggerable and retriggerable monostable multivibrator using a logic gate. So in the basic monostable circuit discussed in the previous section provides an output pulse of predetermined width and response to the input trigger. So after the circuit is going to be triggered, that means monostable is going to be triggered, the output of the monostable goes into the coffee stable state and it will be time out automatically and come back to the stable state. So the width of this pulse is determined by the value of R and C in basic monostable circuit. And using the triple five, it is only negative trigger. That means at the trigger terminal in number 2, the trigger voltage changing from high to low, then and then only the circuit is going to be triggered. When its voltage is going to be less than 1 by 3 VCC, circuit is going to be triggered and output will go into the half stable state and it will be time out after predetermined length of the time. This is the normal monostable circuits. Now, sometimes it is required that circuit should be positive edge triggered also, or it can be negative edge triggered also. In some applications, we require that when the trigger pulse is changing from low to high, then the circuit should be triggered. Or when it is changing from high to low, then the circuit should be triggered. And for that purpose, here prior to the trigger terminal, there are certain logic gates are going to be utilized. And that way, that possibility that it can be positive trigger or it can be negative trigger, that can be derived. And which is available in these two ICs. The logic gates have been added to the input of number of commercially available monostable circuits to facilitate the use of this circuit as a general purpose delay elements. The 74121 non-retriggerable and 74123 retriggerable monostable are two such widely used circuits. Now you will be having a question, what is the meaning of retriggerable and non-retriggerable? So once the circuit is to be triggered by the trigger pulse at the pin number 2, it will go into the cost stable state. And once it is in a cost stable state, if you provide another trigger pulse, will it respond to that trigger pulse? If it is not responding to the trigger pulse, and if it is time out, depending upon the value of R and C, and then it will wait for the next trigger pulse to be triggered. That is called non-retriggerable. But if there are circuits in which once it is to be triggered by a pulse at the trigger input, and then after it goes, output will go into the cost stable state, and then after, if there is another trigger pulse is to be there, before it is going to be time out, there is another trigger pulse is also going to be there, and that is again it is triggering the circuit. That means it will not be time out after depending upon the value of R and C, but it is going to be remains re-triggered until the last trigger pulse is going to be available. So that is called re-triggerable monostable, and that is the IC 74123 will be there. The logic inputs on either of the circuit can be used to allow the triggering of the device on either a high to low transition, which is called negative transition. From high to low transition is known as a negative transition, negative edge trigger, or on a low to high transition that is positive trigger, or it is called positive transition. Whenever the value of the input logic equation changing from false to true, the circuit will be triggered. That means at the trigger input, the circuit must be triggered when it makes a transition from false to true. False means 0 and true means 1. So when it makes the transition from low to high, that means from 0 to 1, then the circuit will be triggered. Both the circuits 74121 and 74123 require this trigger from false to true. Then the circuit will be triggered and the output will go into the quasi stable state and it will be timeout depending upon the external component RNC connected. Take care to note that the transition from false to true must occur, and simply holding the input logic equation into true state will have no effect. That means the circuit must have the transition from false to true, from 0 to 1, from low to high. That transition must be there, then and then only the circuit will be triggered. If the input pulse is going to be remains into the high state or it is remains into the low state, it will not trigger the circuit. The logic diagram, truth table, and typical waveform for a 74121 are given in figure 7.16. The input to the 74121 are A1 bar, A2 bar, and B. So there are three inputs A1 bar, A2 bar, and B. This input decides that where you give the clock pulse so that it can be positive is triggered or it can be negative is triggered. So that way more number of inputs are created to get the options for positive triggering as well as negative triggering. The trigger input to the monostable appear at the output of the AND gate. Here is how the gate works. 1. There are these conditions. If B input is going to be held high and negative transition at either A1 bar or A2 bar, these are the two inputs of bubble or gate, will trigger the circuit. So if you want to trigger the circuit with negative transition, then that negative transition should be given at either of this input, A1 bar or A2 bar. But then the B input should be kept in the high state. Then it is working as a negative trigger circuit. This corresponds to the bottom two entry in the truth table. So we'll see the truth table also simultaneously. This is the two bottom entry of the truth table. So if B is going to be held high, in both the cases, you see that B input is normally utilized for the positive transition. Remember here, you can say that up arrow indicates the positive transition from low to high, and down arrow represents the negative transition, that is going from high to low transition, which is also mentioned here, high to low transition and low to high transition. So if you want to operate as a negative is triggered, the input must be given either A1 bar or A2 bar. That means pin number 3 or pin number 4, that is utilized for negative transition, and pin number 5 of this IC is going to be utilized for the positive transition. So to make a negative transition, A1 bar or A2 bar, that is either A1 bar is going to be making a negative transition or A2 bar is making a negative transition. Then other input should be high. Both A2 bar is supposed to be high, B is supposed to be high, or A1 bar is going to be high and B is going to be high. Then the trigger terminals, output of this AND gate, that is the trigger terminals to the 74121, that makes a transition from false to true, and that means the circuit is going to be triggered and output will make a transition from stable state to unstable state or quasi-stable state. It will reside into this quasi-stable state for predetermined length of the time, which is decided by this value of R and C. So that time period or pulse duration T is equal to 0.69 R into C will be there, and then after automatically it will time out and come back to the stable state, that is in the slow state, and that way the pulse duration or pulse will be generated here. Now to make a positive transition, what is required? So make a positive transition, the pulse should be transition should be given at the B input, and either A1 bar should be low or A2 bar should be low. Other input, that is when A1 bar is going to be low, other input A2 bar can be anything, 0 or 1, makes no difference. Then If there is a positive transition at B, that will trigger the circuit. Or if even bar is going to be anything, B is low and positive transition will trigger the circuit. So there are four different ways you can trigger the circuit. Either positive transition trigger is going to be there or negative trigger is going to be there. This can be also seen in the waveform. This is regarding the negative transition. Even bar is making a transition from low, high to low, that is a negative transition. At that time, A2 bar can be anything, high or low, no problem. B is remains to be high. Then the trigger pulse is going to be available, which is changing the output of the AND gate, which is changing from pulse to true. And that trigger pulse is triggering the circuit, and output of at Q will go from stable state to unstable state, or from low to high. It will reside into the high state for certain period of time, that is decided by R and C. That T is equal to 0.669 R into C, and then automatically it will be time bound. Here also again, instead of you want to make a negative transition from A1 bar, you can make it negative transition from A2 bar also. That means A1 bar is going to be high or low, anything. But A2 bar and makes a negative transition, then the trigger pulse will be available and the circuit is going to be triggered. So either A1 bar or A2 bar, these are the two inputs from where the negative transition of this IC will be possible. You want to make a positive triggering? That means A1 bar is low or A2 bar is going to be low. Then other input should be high, and B is going to be making a positive transition from low to high. Then the trigger pulse is going to be available, and that trigger pulse will see that monostable will go into the quasi-stable state, and it will be timeout after 0.69 or into C. So that way, the positive transition, if you are interested, then it should be given to the B input. Negative transition is required, then the trigger pulse should be given at either A1 bar or A2 bar input. If either A1 bar or A2 bar or both are held low, and positive transition at B will trigger the circuit. This corresponds to the top two entry in the truth table. A logic equation for the trigger input can be written as T is equal to, this is the trigger input from false to true must occur. That is equal to A1 plus A2 B Q bar. Note that for the T to be true, that means T to make from 0 to 1 high, either A1 or A2 must be true. That means this is OR gate. So one of the inputs should be high. Then the output of this AND gate, which is having three inputs. One of the input is output of the OR gate, which is having A1 plus A2. Another input is B, and third input is Q bar, that is the input of AND gate. So output of the AND gate is changing from low to high when Q bar is going to be high. So when it is in a quasi stable state, what is the position of Q bar? Q bar will be low because Q is going to be high. So Q bar will be low in a quasi stable state. At that time, when quasi stable state is going to be there, that means T cannot be true or it cannot be 1, and hence the circuit cannot be re-triggerable. So you understand, this is the reason why this IC or this circuit particularly behaves as a non-re-triggerable monostable. Logic equation for this trigger input can be written as T is equal to A1 plus A2 B Q bar. Note that T to be true, either A1 or A2 must be true. That is, either A1 bar or A2 bar at the gate input must be low. Also, since Q bar is low during the timing cycle, that means in a quasi stable state, it is not possible for a transition to occur at T during this time. The logic equation for T must be low if Q bar is low. In other words, once the monostable has been triggered into quasi-stable state, it must time out and switch back to the stable state before it can be triggered again. So this way, this circuit works as a non-retriggerable monostable multivibrator. Remember this important. The output pulse width at Q is set according to the values of the timing resistance R and C, as C is equal to 0.69 the value of RA C. Now one example is given. For example, if C is equal to 1 microfarad capacitance, that means 10 raised to minus 6 farad, and R is equal to 10 kilo ohms, that means 10 into 10 raised to 3, so 10 raised to 4 ohms. The output pulse width will be 0.69 into 10 raised to 4 ohms into 10 raised to minus 6 Faraday. That comes out to be 6.9 milliseconds. So 6.9 into 10 raised to minus 3 seconds. That is called milliseconds. So 6.9 millisecond pulse duration will be there. Now, example related with this. The 74121 monostable in figure 7.16 is connected with R is equal to 1 kilo ohms and C is equal to 10,000 TF. Pin number 3 and 4 are tied to the ground. That means A1 bar and A2 bar is grounded. And series of positive pulses are applied to the pin number 5. That means their series of positive pulses are applied at the input B. Describe the expected waveform at pin number 6. Assume that the input pulses are spaced by A if it is going to be 10 microseconds and B if it is spaced by 5 microseconds. First of all, what is the pulse duration? That we will find out using the formula 0.69 R into 6. The circuit is connected such that positive pulses applied to the pin number 5 will trigger it. The output pulse width at pin number 6 will be T is equal to 0.69 into 10 raised to 3 because 1 kilo ohms resistance is there, and C is equal to 10 raised to minus 8 will be there because 10,000 TF. So 10,000 into 10 raised to minus 12, that is going to be 10 raised to minus 8. So that comes out to be 6.9 microseconds. 6.9 into 10 raised to minus 6 seconds. That is called 6.9 microseconds per liter. Now, what are the input pulses which are going to be spaced? 10 microseconds and 5 microseconds. The monostable will trigger and time out for every input pulse appearing at B, as shown in the figure 7.178. Since the monostable is not retriggerable, it will trigger once and time out for every other input pulse as shown in the figure 7.17b. You see this circuit. If at the input B, the pulses which are given, which are spaced by 10 microseconds like that. So the first positive transition will take place at T. That means positive trigger will be there. The circuit is going to be triggered and it will go into the quasi-stable state. It will be timeout after 6.9 microseconds. And it is already in the stable state before second positive age is going to be occur. So you can see that if this is the condition, this circuit is going to be triggered every time and it will be timeout with every 6.9 microseconds every clock pulse. First clock pulse, second clock pulse, third clock pulse, and so on. But in second case, if the pulse which are going to be given or the clock pulse which are given is of 5 microseconds. So on a first positive transition, the circuit will go into the quasi-stable state, but it will be time out only after 6.9 microseconds, nearly 7 microseconds. So before that, the second positive transition has occurred, but it is not going to be respond to the second positive transition because it is not retriggerable. So for this trigger pulse, it is not responding and or it will be time out only after 6.9 microseconds. After 6.9 microseconds, it is already in the stable state. So when there is a third clock pulse which is there, that is positive transition will take place, it will be triggered again and it will be time out. So not at every trigger pulse it is going to be triggered, but it is going to be triggered for the first clock pulse, then the third clock pulse, then the fifth clock pulse, like that way. So this way the circuit is going to be waveform is going to be obtained. Now there is another IC we are going to study, and that is IC 74123, which is retriggerable monostable circuit. The logic diagram and truth table for 74123 retriggerable monostable are also given in figure 7.80. There are actually two circuits in each 16-pin DIP and the pin numbers are given for one of them. That means in this IC 74123 there are two set of retriggerable monostable circuits are adjusted or it is to be packed. And one of the circuits, the pin numbers are given here. This IC is of 16-pin dual inline package TTL IC set. The input logic is simpler than that of 74121. The inputs are here. Also, there are three inputs: A bar, B, and R bar. And the truth table summarizes the operation of the circuit. The first entry in the truth table shows that the circuit will trigger if R bar and B are both high and negative transition occur at A bar. That means if you want to utilize this circuit, when the negative transition will take place at the trigger terminal, then the circuit will be triggered, then the trigger pulse should be applied at A bar. But for that, R bar and B should be kept high, and the negative transition at A bar will trigger the circuit. Now, the second entry in the system state that circuit will trigger if A bar is held low, R bar is held high, and positive transition occur at B. That will also trigger the circuit. The third entry into the truth table: if A bar is low, B is high, and positive transition at R bar will trigger the circuit. So there is a third condition that positive transition also at R bar also can trigger the circuit if A bar is low, B is going to be high, and positive transition will trigger the circuit. So there are three ways the circuit can be triggered. The last two entries in the truth table deals with the direct reset of the circuit. Reset of the circuit means even if it is in a quasi-stable state, anytime if the reset terminal is to be activated, the output pulse is going to be intermittent and output is going to be changed immediately from high to low. That means it will not wait for timeout, but anytime it will be reset to the low state. That is called the reset input activity. So last two entry deals with the direct reset of the circuit. Irrespective of the value of A bar or B, if the reset input R input is negative transition or is held low, the circuit will immediately reset. This is R bar, sorry. The logic equation for the trigger input to the monostable can be written as P is equal to AP R bar. Notice that the state of the output Q does not appear in this equation as it does for 74121. So in trigger terminals, this equation AB R bar. Here there is a no state of the output Q or Q bar. That means it does not depend upon the output. So output may be in a stable state or unstable state. As whenever this condition is to be occurred, the circuit is to be triggered. So it can be re-trigger also. This is the meaning of this. This means that the circuit will trigger every time there is a positive transition at T will occur from this condition. In other words, this is a re-triggerable monostable. The output pulse width at Q for the 74123 set by the value of the timing resistance R and C of the capacitor C. So you can see that if you want to make it negative age trigger, that means the pin number 1, you have to provide the pulses. And when it makes a negative transition at here, you can see that this is from A bar. Yeah, this is a mistake. Be careful. This should be the down arrow. So when there is a down arrow, negative transition will be there. B is going to be high, R bar is going to be high, then negative transition and A bar will trigger the circuit. Remember this. Second conditions, if A bar is going to be low, B is making the transition from low to high. That means there is a positive transition. This arrow is correct. And R bar is going to be high. Then the circuit is going to be triggered. Third condition. If A bar is going to be low, B is going to be high, and there is a positive transition from low to high. So the circuit is going to be triggered. From low to high, this circuit is going to be triggered. That means output of the trigger is also making a transition from false to true. And that means circuit is going to be triggered, and the output of this one will go into the quasi stable state. It will reside into the quasi stable state for a predetermined length of the time that is decided by the value of R and C, that is 0.33 into RC, that is the time duration for which it remains in the quasi stable state. Then after it will come back to the stable state or in a low state. These two last entry, A bar can be anything, B can be anything. That means XX stand for don't care, whatever it may be low or high. But if R bar is going to be low or R bar is changing from high to low, that means this terminal is going to be activated. You can see that here there is a bubble is here. So the circuit is going to be reset immediately. Reset means this output is going to be this output is going to be reset immediately. Anywhere it may be. It does not wait for the timeout. But at any time, this terminal is going to be activated, reset terminal is going to be activated, output is changing from high to low at that instant immediately. And that way, the timing duration is going to be interrupted. That is the meaning of resetting. It can be approximately the equation T is equal to 0.33 R into C. The waveform in the figure 1.19c shows a series of negative pulses used to trigger the 7412 tree. Notice carefully that circuit trigger Q goes high at the first high to low transition on A bar, but that the next two negative pulses on A re-trigger the circuit, and the timing cycle T does not begin until the very last trigger. You see that B is going to be high, R bar is going to be high. So when the first high to low negative transition will be there, this is negative trigger is going to be there. Circuit will be triggered. That means Q will be going from stable state to unstable state. That means from low to high, and it will be reside into the high state. Now during that time, because it is re-triggerable, when the second clock pulse is going to be there, again it is going to be re-triggered, and because it has not time out, the value of R and C is selected such that that timing period is to be larger. So what happens in already it is in a constant stable state. At that time, there is a second trigger pulse is to be there. Again, it will be re-triggered. There is a third trigger pulse is going to be there. Again, it is going to be re-triggered. But thereafter, there is no trigger pulse. It is going to be remains high. So what happens? The triggering time is going to be this. So it will be time out after this 0.33 RC time period, and it will come back to the stable state. So that way the clock period or pulse width can be changed using retriggerable monostable multivibrator. Example related with this one. The 74123 in figure 7.18 is connected with A bar at a ground, that means A bar is low, R bar at VCC, that is very high, and R is equal to 10 kilo ohms resistance, C is equal to 10,000 PF. Describe the expected waveform at Q. Assuming that series of positive pulses are applied at B, and the pulses are spaced by 50 microseconds, or it may be spaced by 10 microseconds, then what is going to happen? The solution. The output pulse width will be T is equal to 0.33 R into C. R is equal to 10 kilo ohms. So 10 into 10 raised to 3, so 10 raised to 4. And C is equal to 10,000 PF. So 10,000 means 10 raised to 4 into 10 raised to minus 12. So that will be 10 raised to minus 8. And that comes out to be 33 into 10 raised to minus 6. So that is called 33 microseconds. Now, this is the pulse width time. So predetermined length of the time. It will be timeout after 33 microseconds every time once it is to be triggered. The circuit will trigger and time out every pulse as shown in figure 1.98. The circuit will trigger with the first pulse and then re-trigger with every following pulse. The timing cycle will be reset with every input pulse and Q will simply remain high since the circuit will never be allowed to time out. See in figure 7.90b. If the pulses at B are stopped, the Q will be allowed to time out and will go low 33 microseconds after the last pulse at B. So you can see that because the pulse duration is going to be 33 microseconds and the clock pulses which is given which are spaced by 50 microseconds. So before the second positive edge comes, you can see that this has already come into the stable state. So again it can be triggered here and again it will be time out after 33 microseconds and it is ready to trigger for the third clock pulse. So on every positive transition, the circuit is going to be triggered and it will be time out in a first case. But if the clock pulses which are given, which are spaced of 10 microseconds, so after the 10 microseconds, second trigger pulse will be there. So before it is to be time out, that is 33 microseconds, it has already obtained another trigger pulse. So it will be re-triggered and you can see that it is going to be continued and output remains into the high state only until the last trigger pulse. When the last trigger pulse, when the positive transition will be there, it will be triggered, re-trigger again and output timing cycle is going to start counting from here because then after there is no trigger pulses there. So after this, after 33 microseconds, automatically it will time out and it will be low. And this way, the pulse duration can be modified here. Thank you very much.